No, just okay. Okay, so some of you guys said, well, what about 3-1 and 3-2? Okay, so just in case you're incredibly curious, I did put the 3-1 and 3-2 stuff into OneNote so you can take a look, but 3-1 is like just going over the definition of a derivative, which we already learned. So they're just like using it in its application sense. Okay, so I was already telling you that it is finding the derivative. Okay, so it's just reinstating that idea. And then 3-2 talks about differentiability, like when you can and cannot take a derivative. So we'll talk about that as we kind of go. So if you're curious, you can look in there. But the 3.3 is rules for differentiation. So there's actually 3 rules in here that are all kind of squished together. The first one that we're going to talk about is the power rule. Okay, so the power rule is right there. And then we'll talk about sum and difference, which is technically just deriving each term. And then tomorrow we'll talk about product and quotient. Okay, so taking the derivative. As of right now, all you know is that in order for us to derive, we have to use this limit definition, yeah? Okay, well, there happens to be some tricks. Okay, I know you're shocked by this, but there are tricks into using the difference quotient that make life way easier. So, oh yes, even maybe less than 5 seconds. So, the power rule. Okay, so if you're given a single term, okay, here is the definition of a power rule. Okay, so what this says is if we have a function, let's say our function is x to the nth power. Okay, if we derive it, so that d dx is just notation, meaning we're deriving it in terms of x. So deriving x to the nth, and all that we have to do is we take the exponent, we put it out in front, and then subtract 1 from the exponent for a new one. Okay. So this is the power rule. What? What? What was that? Oh. D over dx means we're taking the derivative of x to the n. So this is just notation. Okay, example?
No, I think I understand it already.
N minus 1.
Can you just take the test? Yeah, test me.
All right, I'm gonna just make one up because I know I have one somewhere, but it's just fine. All right, so example number 1. Okay, so let's say I have an equation, which is y in this case, and it's 3x squared plus 5x minus 2. Okay, so if I say find the derivative, okay, the derivative, we've been using the notation of y prime for derivative, right? So just so you know, that same notation would be dy dx. Okay, you saw that previously, d dx just means we're deriving in terms of x. Okay, so we're going to derive each term individually. So if I have 3x squared, what is the exponent that I have? 2. So all I'm going to do is I'm going to take the 2 and I'm going to multiply by the value that's in front of the x. So 2 times 3 makes 6. So then I have 6x, and now my new exponent is going to be 1 less than it was before. So what's my new exponent? 1. The next one? Okay, so the next one, yeah, everybody's okay with 5? Yeah. Because there's an exponent of 1 times 5, and then we lose 1, so the x goes away. Does anybody know what the derivative of a constant is? 0. Okay, so negative 2 is always 0. Okay, because if we were going to think of a line that's just y equals negative 2, right? Remember that derivative is analyzing the slope of a line at a specific spot. Okay, so if I have a horizontal line, call it negative 2, what's the slope of any horizontal line? 0. So the derivative of any constant is always 0. Okay, so That's it.
You just take the x out.
Yeah, you take the x out.
So wait, so what if it was 3x cubed?
Okay, so let's do another one.
Do we always have to put dy over dx?
Nope, you don't have to. You can just write y prime.
Okay.
All right, let's make it really hard. 2x to the... No, that's too big. 6 minus 4x squared plus x. Okay, let's try this one.
Oh, plus x.
Ooh, tricky, right?
That's gonna be 1.
Okay, so if I gave that to you 3 days ago, or, well, a week ago, yeah, you would have cried, right? If I would have given you something to the 6th power, that would have been nasty. Okay, but now with this basic trick, it's a piece of cake. Okay, so what am I going to multiply first? 2/3 times 6. Anybody know what 2/3 times 6 is? Wow, good. 4x to the 5th. Very nice. What? So easy, right? You just take 1 away. Okay, what's my middle term going to be?
So do you take -4 or do you, I guess the jokes would be the same. 8 minus
Other one.
8x.
8x. Same thing.
Oh wait, it's an x squared.
Okay, what is the derivative of x?
1.
Plus 1. Perfect.
No, I didn't.
Okay, how did everybody do there?
So how did you get that? Did you keep on?
How did I get 4? 4 is 2/3 times 6. Why did...
Okay, so that was like, so how do these get
It's not... Okay, so let's
These are the
do...
same answers we'd be getting if we used that same.
Yeah, right?
Why did you even teach
It's like, I just enjoy torturing you.
So wait, so then you don't have to derive the 5.
Derive the 5.
No,
Like the 5, the 5, the x, the 5.
No, we get... No, we don't derive it. That we just got it because we subtracted 1 from the 6. So no, you don't try that.
Can you do it again?
Yeah, let's do another one. You mean drive again?
Yeah.
Oh yeah, you could drive
Are you supposed
till you
to?
get 0.
Why not days? Why don't you? Why not?
Because the purpose is the first derivative gives you the slope of the tangent line. We will take a second derivative. Second derivative gives you concavity, so curvature.
I totally know that.
So you can tell. Yep, so you can tell if it's like this or like this.
Let's not go there. It's okay.
Yeah. Okay, so let's try another one. Ooh, let's try negative.
What?
You're gonna do it.
Okay. So now this one, I cannot derive the way it is written.
You have to type by that.
Okay? This question, I have to start by simplifying it before I can do that. Okay? So, since everything is being divided by x, I'm going to divide everything by x. So, when I simplify, what is my first term going to be?
Negative 8x to the third.
Negative 8x to the third. What's my second term going to be?
2x to the second.
2x squared. Third term? 2 plus 2. So now when I derive this, what is my first term? Negative 24x squared. Second term? 4x.
0.
Plus 0. Perfect.
Okay, I like this.
Okay. Let's try another one. Let's try 3 over x squared plus 2 over x to the 5th minus 1 over x. Okay, so this is the same thing. I cannot derive this as it is written. I have to start by rewriting this. Okay, I can't work with x's in the bottom. So when I pull them up, how do I rewrite them? As a negative exponent. So this becomes 3x to the negative second plus 2x to the negative 5th minus x to the negative first. And now it's in a basic form, and I can use the power rule. Okay, so if I derive my first term, what's the first term going to become?
Negative 6x to the
Negative third. Good. So remember, you're still subtracting, so this gets tricky when you subtract from a negative. Be careful. Okay, what's my second term going to be?
negative 10x.
Good. Negative 10x to the negative 6. And my third term? Oops. Plus x to the negative second. Now, I don't want to leave it this way. This is technically unsimplified. I have negative exponents. So how do I rewrite that correctly? Not square roots. If I have a negative exponent,
When you just put it back,
just a fraction. There you go. So I'm going to have 6 over x to the third minus 10 over x to the sixth plus, what's my last one going to be?
1 over
1 over x squared. Good.
Wait, so is it just that we can't solve them with exponents in the bottom, but that's okay to write our answer as?
Yeah. Well, in calculus you can leave rationals in the bottom, like square roots and stuff. It's only if you're like writing an answer like 2 over
solve the problem now?
Yeah. Okay, so let's do one with a radical.
Is that literally it?
Yeah.
That's all we're doing?
Yeah. Well, yeah. But you're gonna still do like tangents and stuff. So I'll say like find the slope at. Yeah.
But it just saves all the work of that. Seriously.
Okay, so let's say we have the same idea, and I say find the slope at x equals, I don't know, 5. So let's say the equation was the cube root of x plus 5 square roots of x, and we're going to find the slope when the x value is, let's go with 1, so it's nice and safe.
Is it?
Okay, so we're finding the slope. Okay, so the first thing that I have to do is I have to rewrite this so that it's in my basic form. So how do you write a cube root? X to the 1/3. So if it's in the bottom, how do I pull it up? X to the negative 1/3. Okay, what's my second term going to be?
5x to the negative 1/2.
5x to the negative 1/2.
You just put in 1 for the x.
Okay, so now I derive it. Yep, so now we're going to derive it. Okay, so if I derive it, remember I'm multiplying, so what's my first term going to be? Negative 2/3 x to the negative 4/3. Nice. Negative 4/3. Okay, second term, what's my second term going to be?
5/2.
So minus 5/2 x to the negative 3/2. Good. Okay, so then I would technically have to simplify this because both have negative exponents, right?
Why did they go up by?
You have to simplify it?
Because you're subtracting 1. So if I'm subtracting 1, both of those were in terms of thirds. Well, the first one was in terms of thirds. So thirds would be 3/3, or 1 would be 3/3.
Can you just plug in the x?
You could. You just have to be careful of how you do it.
Oh,
So to the 4/3. And then the second one would be 5 over 2. So do you see how I'm keeping that 2 in the bottom and the 3 in the bottom with the x? Okay, and I'm not going to even convert it back to radical form. I'm just going to keep it in exponential form. Okay, so now for me to find the slope when the x value is 1, what do I do? You plug it in. Good. So if I plug in, notice the notation for that. So plugging in 1 into the x. So first term, I'm going to get negative 2/3, right? Is everybody with me? Because you got 1 to the who cares power is always 1. And then what's my second term going to be? Minus 5/2. Okay, so if I'm subtracting fractions, what do I have to have? So what's my common denominator? 6. So if I rewrite my first one, it's going to be negative 4/6 minus 15, 6. Now subtract the tops. Negative 19, 6. Okay, so that would be the slope of the line when the x value is 1.
And then
Okay, so we could even go further and say, okay, now write the equation of the normal or the tangent line. Okay, so they probably would give you a point there for that one. Huh? Yeah, they'd give you a y. Oh. Well, we could just take the x value and plug it into the original. Yeah, it's ugly. I wouldn't give you one that next. Okay, that's it.